So if you're going to solve this, what would you do? If you want to get x alone, you'd have to do something to get x alone. Like if it was 5x equals 11, you could do something. You could divide by 5 and the x would be alone. I just want to show you what I mean by being alone. See, x is alone, answer is 11 over 5. Can you get x alone? Well, no. That's what we need logs for. So logarithms is a whole other branch of math. And I'm going to just write this one under it, and I want you to also. Log with a little 5. It's a subscript, so don't think it's times, because it's not. It's a subscript. Log base 5, 11 equals x. Now, being able to go back and forth between that red one was called an exponential because there was an x in the exponent. And this thing on the bottom that's in white, that one is called a log. Being able to go back between exponentials and logs is half the battle. If you can write the one as the other, if you know how to go back and forth between them, which is what I'm teaching you today, that's one of the main things. They're related to each other. I call them sisters of each other. But they're not identical twins because they don't look alike, but they're sisters. All right, so let me explain why you would even want to do this. Because the x is alone now, and that can be calculated with a calculator. Don't get out the calculator, because this whole test, we're not going to use calculators. Why? Well, if we needed the exact answer for this, this answer is good enough. That is the exact answer. Log base 5 of 11 is good enough. It's kind of like saying 22 over 7 is the answer. Would you insist that I make it a decimal? No, 22 sevenths is fine all by itself. By the way, if you wanted the decimal, it's 3.14. True. It's not 3.14159.26535. Like, it's not the actual real pi, but it's the best approximation of pi we have. So my point is, you wouldn't look at that and say, that's wrong. You have to make a decimal. No, it's fine by itself. This isn't wrong. You don't have to make it a decimal. Now, if you kind of want to know about what it is, you could just say, well, is 5 to the 1 equal to 11? No, it needs to be bigger. Is 5 to the second equal to 11? No, that's too big. So do you get the answers between 1 and 2 and it's a decimal? All right. Now, in the old days, they could do this two different ways. They had whole printed out books, and you'd like look up log base 5 of 11 in this printed out book. Or they had a thing called slide rules, which is this plastic thing, and it had numbers written on it, and you pulled one piece of plastic out of the other piece of plastic and lined some things up, and they could calculate these really fast by using a thing called a slide rule. Nowadays, of course, it's calculators, or even more advanced than a calculator, an AI. I spend a lot more time now talking to AIs because I have access to them, and they're really smart, and I get good advice. And anyway, so I would probably just ask my AI, what's log base 5 of 11? Now, you may have noticed I said that in a different way than you might have. Most kids, if challenged to say this thing, they'd say log 511. But that shows they don't know what they're talking about. A little bit like if your grandpa saw this written, he might call it Wi-Fi. And you'd be like, what? Unless your grandpa's, like on top of things and knows it's Wi-Fi, you'd probably be nice and not correct him, but you'd be like, Grandpa doesn't know what he's talking about. That's not Wi-Fi. It's Wi-Fi, and it's a whole thing. It's not just that you don't know how to say it. If you say log 511, I judge you because you don't know how to say this right. So I'm going to show you how to say it. You say log base. It's not written, but you're supposed to know it. Log base 5 of 11. Now you actually sound like you know what you're talking about. Log base 5 of 11. That's how you say that. Okay? All right. A few other things. I don't make you write down tons of notes. This is what I would consider notes. You're not going to just remember that. You think you are, but you're not. Now here's a few more things you've got to know about this. This, not surprisingly, is called the base. This has a name. The name is not of course. Okay, that is called the argument. I'm fine with you just abbreviating it, arg. That is called the argument. And this last part here is called the exponent. So there's the base, the argument, and the exponent. There's always three parts to a log. The base, the argument, the exponent. Okay. We'll try to keep your notes mushed together all in this one spot here. Now look at that x being the exponent, and I know it doesn't look like an exponent. It's kind of annoying. It's like, that's not an exponent. It's a base. It's like sitting there by itself. It's not as a power. But look at the original problem. Do you get it? It used to be up there. It used to be an exponent. So if you write it in the way that its sister was written, it was an exponent. That's why they call it the exponents. Because if you rewrite this thing, it'll go up as a power. Okay, now, would you agree that if a teacher only taught you how to go from a fraction to a decimal and never taught them how to go from a decimal to a fraction, that would be bad. If you only knew how to go this way, but you couldn't go the other way. Well, you have to be able to do logs both ways. Sometimes they give you a log and you have to undo it and make it not be a log. So please write this down. I'm going to write log with a little 3 and an 8. Actually, I'm wrong. I'm going to make that a 9. Sorry. Everybody change that 8 to a 9. The first challenge is, do you even know how to say it yet? It's not log 3, 9. Log base 3 of 9. There you go. That's how you say it. Log base 3 of 9. And I know the answer. And I think there's going to be several of you that are going to know what the answer is too. Just use your big brain. Take your best guess. And please talk to the kid next to you. What do you think the answer is to log base 3, 9? Log base 3 of 9. All right. It's 2. How many of you guessed 2? A bunch of you. Nice. Now, if you're like, I don't get at all what we're doing here, and I understand. You will, and you will later. All right. So if you want to make a log turn into not being a log, you have to be able to do what I call the circle of logs. This, you start with this 3. It goes to the power of whatever's over there. And again, I want to erase. I know the answer comes out to 2, but I just want to have the x there for now. So if I go from the 3 to the x, that's 3 to the x. And it comes back here, equals 9. From looking at that, can't you tell that x would be 2? Because 3 to the 2 equals 9, right? All right, cool. So that was going from a log to, we had a whole test on it. What are they called again? It starts with an E. Exponential. Good. From a log to an exponential. But if I had an exponential, could you make a log? No. Log. And then what's the base? Just look at it and tell me the base. It's easy. 3. And you're going to do the circle of logs. 9 is next. Back to the x. And we can keep going forever. Now it's a log. Let's make it into an exponential. 3 to the x equals 9. I know you don't want to keep doing it forever, and I won't do it forever, but my point is you can go back and forth between them. So which one's better? This one or this one? Well, it depends what you want. If you want the x alone, this one's better. So if you want to ask to solve for x, the top one's better because x is alone. If you wanted to figure out what x was, the exponential way is probably better because you can go 3 to the what is 9 and you can go, oh, this must be a 2. All right. All right, so let's make sure you really get going back and forth. If I wrote log base 2 of 11 equals x, can you get that so it's not a log? Circle of logs. I'm gonna send this around. You may remember this started as a little tiny bit of seeds at the very bottom, and it's all grown up now. But I want to talk about how it was exponential for a while, but it's not anymore. It might even still be growing a tiny bit, but it certainly isn't growing as fast as it was. For those at home, we're looking at this jar. I put seeds in this jar, and the seeds are now way out the top. If you were to graph that growth, you get it was really explosive growth, and then it slowed down, and now eventually, like, are those beans going to keep growing forever? No, they're going to limit. They're going to limit off. There's a special math function that you'll learn about in pre-calc that starts off exponential and then slows down and flattens out. So there's actually an asymptote on top, because beans can only grow so high. Like, think about it. Even a tree. Trees can't keep growing forever. They only grow so high. Even the most healthy, perfect walnut tree is only going to get so high. So that's a special function, and it's called the basic logistic function. You'll learn that one in pre-calc. But the point is, it started out exponential and then slowed down. A lot of things like do that in real life. Like, you put two rabbits together, and they make more rabbits, and they make rower rabbits, and then if they didn't stop, then all of a sudden we'd be like walking through knee deep of rabbits outside, and eventually it would be over your head in rabbits outside. Okay, so why does it stop? Well, they have predators, and they run out of food, and then it levels off like this. The population levels off at a certain point. Okay, good enough. Did you turn that into 2 to the x equals 11? Raise your hand if you did. Nice. Now, I totally get, you don't know this answer. 2 to the what is 11? I don't know. But what's it between? Like, is it between 4 and 5? 3 and 4. It's between 3 and 4. 2 to the third is 8, and that's too small. 2 to the 4 is 16, and that's too big, so it's between 3 and 4. So it's 3 point something. Can you get the idea? You can get a decimal for it in your head by just kind of estimating. It's 3 point something. All right. Now, your little, not test, but in a second, I'm going to ask you to compare with the kid next to you. Have you guys all seen the jar? Okay, just hand it forward. And I'm going to ask you to talk to the kid next to you about how to say this. So turn to the kid next to you, and I'm going to go 1, 2, 3, and then you're all going to say it to each other correctly. All right? Okay, and it starts with the word log. All right. Turn to that person next to you. 1, 2, 3, go. All right. I think a lot of people have missed the of. Log base 2 of 11. Maybe it was just quiet and you couldn't hear it. All right, so log base 2 of 11. Now you know how to say it, so you won't look dumb when I ask you to read problem 1 and you're like, log 211? It's not a thing. Log base 2 of 11 is a thing. All right, next I got to tell you the rules for these things. Got to have rules in math. This is a whole different area of math, but you knew this rule. What can x not be? In this, there's something x can't be. It's not legal. You can't let x be something. You must have forgotten. If x was 0, you'd have 1 divided by 0. That's not legal. You can't put in 1 divided by 0. That's never okay. All right? So that's one of the rules of math is you can't divide by 0. Well, there's some rules for logs. And it goes like this. These two numbers have to always be positive. So they can't be 0 and they can't be negative. Okay? And there's one more rule. That little lower number, the base, that can't be 1. So they both had to be positive. This is the easy part. And I'll explain why the base can't be 1. Let me show you. If I had log base 1 of x equals 4, it would set up an impossible situation. Nope, I'm wrong. Actually, it could work in that situation. It's this situation. Because if I had this, which again is illegal, because you can't have a 1 base, then 1 to the 4, 1 to the x would have to equal 4. And if you process this long enough, you will realize that that is impossible. Because guess what 1 to the anything is? 1. You might be like, what about 1 to the 0? Still 1. How about 1 to the negative 1? That means flip it. It's still 1. How about 1 to the third? It's still 1. How about that 1/3 root of 1? It's 1. It's always 1. So there's no way it could be 4. That's why you can't have a 1 base. All right? So there's some rules about the base and the argument. Basically, the main thing is they can't be negative and they can't be 0. So they have to be positive numbers. Can they be fractions? Yes. The only other rule is base can't be 1. All right. I have learned almost everything. So some of the questions for today are as simple as log base m of q equals p. And they'll say, what was the base? And what would you say? M. How about this? What is q called? The argument. What's the p called? Exponent. Could q be 1? Yes. Could q be 0? No. Could m be 0? No. Because these can't be 0. And they have to be positive. All right? Okay, cool. Now you got to be able to solve some of these in your head. If I said log base 2 of 4 equals x, some of you are just going to go in your head, ooh, 2 to the what equals 4? And you're going to be able to solve it that way. And that's awesome. 2 to the what is 4? X must be what? 2. But there's another way that I think you'll find is way faster. And that's this. Would you agree that that 4 could be written as 2 squared? If you do that, you have made the bases the same. And I'm about to say a very powerful statement. If the bases are the same, then the answer is already there. It's right there. That's the answer. If you can make the bases the same, then that'll be the answer. I'll show you why. Because 2 to the x is equal to 2 squared. So the bases are the same. So the answer's already there. See? So it's really fast if we give you like log base 3 of 9. You can just go, oh, that one's 2. Because you don't have to do a rewrite of an equation. You can just go, that would be like 3 squared, right? So the answer is the exponent. It's 2. All right, here's where they stretch you a little bit. Because we just had this unit, log base 4 of 1/4. What's the answer? Don't say it. Talk to the kid next to you. What do you think you do to get the answer? In this one. Make the bases the same. That's what you do. You know how to do that? Talk to the kid next to you. Come on, you guys. All right, for today, you guys talk. For today, you guys know you should talk to 1/4, right? Okay. Talk to him. You guys talk to him. Talk about it. All right. I think just maybe the reason I'm not getting much talking this time is because you're all stuck. So let me explain. If that's a 4, then I'd be golden. The bases would be the same. So how do I make it be a 4? I look at these two and I go, oh, if it was 4 to the negative 1. See? How many of you knew it was negative 1? Raise your hand if you had negative 1. Okay, good. All right. Then how about this? Go the other way. Log base 1/2 of 8. Kind of a pain in the butt. But you can make 8 into a base of 1/2. Do it. Don't show the kid next to you, just do it yourself. The white question mark is the question. 8 could be 1/2 to the something. First of all, you'd say to yourself, well, it's a fraction, and I don't want it to be a fraction, so negative. It's got to be negative. If I just flip it over, then the 2 has to become an 8. Oh, I can make a 2 into an 8. How many of you figured out it was -3? All right, nice. Why do we do that? Because that's the answer. That's what it's equal to. If you type this into a calculator, it would say 3. No, -3, sorry. I couldn't read my writing. It would say -3. Okay, so you're calculating these logs that are kind of complicated in your head by making the bases the same. Does that sound familiar? Did we do making the bases the same on the last test? All right. Cool. All right. So, what else do we have to know? Well, let's actually go look at the worksheet. Everybody open up the worksheet for this, that I signed for today. It's a little too long, so I'll tell you what some to skip. Turn up your brightness a little bit. All right, we're going to go to problem 4, and we're going to skip some in there. We're going to skip C, G, K, and L. The L is the very last one. C, G, K, and L are the skips. All right, now let's go back to the beginning. I got 2 Aidens, 1 taking the test. The other Aiden, can you tell me what number 1 is? Read it to me like you know what you're talking about. Oh, 1A. Nice. Now, what do they ask you about it? Oh, base is this. Argument's that. Super easy, right? All right, so let's do 1, 2, skip a few. And let's go to problem 2, because those are completely different. Ben W., would you read me 2A? Please.
Log base 3, 9 equals n.
And what do they want me to do?
Rewrite in exponential form.
Ooh, okay, so if you were like extra smart and just said, the answer's 2, that's not what they want. They want this written as an exponential, which has the x in the exponent. Little sayings like that always fall down in some way, like, it isn't an x. Well, it's a variable at least. 3 to the n equals 9. And I call that the circle of logs, and that's not a real thing, but there is no name for it, so I like to just call it the circle of logs. All right. Now, it was a log, and now it's not a log. See? It was a log, now it's not. These are sisters of each other. All right. Technically, math-wise, they're inverses of each other's, but these are inverse functions. You don't really know what that means yet, but I'm just pre-telling you. Okay. So, what's this good for? Well, I can do it in my head then. I can go 3 to the 2 is n, so n must be 9, so n must be 2. What's this good for? You could type it in a calculator if you had a calculator, and you could get the answer that way. And n is alone. That's what it's good for. Okay. All right, moving on. Let's go to problem 3, the style that problem 3 represents. Max, would you read me 3A?
5 to the power of n equals 25.
Could you start over again?
5 to the power of n equals 25.
All right, and what do they want me to do?
Write in logarithm.
Oh, so log, and then you do the circle of logs this way. Log base 5 of 25 equals n. See how that worked? You always do the circle. You don't ever do it in order. You don't ever go log base 5 of n is 25. That you don't do it in order. You do it where you go from in the circle. I think that's the best way to say it. You go from one side to the other side and back. Okay. And that was 3A. How about 4A? Mr. Breen, would you read that one?
Log base 3 of 81.
And what do they want me to do?
Simplify it by first writing it in exponential form.
All right. Since they asked for exponential form, I can't do it my favorite way. See, my favorite way would be to just say that's 3 to the 4th, and then I already got the answers 4. But I wouldn't get the credit on the test because I didn't write it as an exponential yet. So what you do is you go equals X. You can do that. It doesn't say what it equals, so I can say equals X. And then you can use a circle of logs. 3 to the X equals, and I think it's just smart to write 3 to the 4th. It is this equal to 81, and it's better because now I can see the base is the same. I know already the answer is 4, see? And I've got my exponential in case they say, well, you didn't write an exponential. That's an exponential. Has the X and the exponent. All right. So now I got to save a bunch of time for handing back those tests. And I will not be able to like talk to you about your test score because I got to get it back to everybody. And from past experience, sometimes I'm like, but why did I get this wrong? Why did I get that wrong? I get it. You want to know, but I got to give you the test back to everybody first. And then one other thing I should tell you, this is our first time where the retake of this is going to be on a cumulative. So for some of you, that's like, yeah, I've done those before last semester. Cool. But do you know that if you have anything lower than an A, like a 95%, you don't have to do any corrections or anything. But if you have anything lower than an A, you have to do corrections. It doesn't have to be on this special sheet, but it has to be on a separate sheet of paper. You might as well grab one of mine. And those corrections have to be done and turned in for you to be able to raise your score with the cumulative test someday. So if you got a B, for example, it's a very common thing, a bunch of people got a B today, you're gonna have probably 3, maybe 4 questions that you have to fix, and you fix them on here, and then you just put your name on top. You don't have to even staple it to the test, we'll just save the staples. Just make sure your name's on both and you turn them back in. So one of the rules when you hand back tests is you can't take a picture of the test. There are some people that haven't even taken the test yet. So I don't want any, that would be heavy duty cheating, call down to the principal, all kinds of nasty things happen. Don't take a picture of your test. But what you can do is take this correction sheet home and correct mistakes you made on your test. That's okay, because this is just a worksheet. Okay, the test I have to keep in the room and you can't take pictures of it. All right, make sense? All right, so I know some of you are new to me this semester, and I know that not everybody requires this. I guess I'm Mr. Meanie Pants. It's gonna be okay. If you got some wrong, you want to know what you did wrong on them so that you do better on the next one, right? So that's your only requirement other than having your homework done. And even that, if you have one missing assignment, it's fine. But if you have like tons of missing assignments, yeah, you're gonna have to fix that too if you want me to replace your score. But anyway, back to this. If you got a B, when you take your test, I know some of you are gonna forget, but try to remember to take one of these correction sheets if you got a B or lower, okay? All right, cool. Now, even if you were absent today, you got to hear that on the video, and that's all I got for today.